Now let's do OR probability, which is a type of compound probability that you use when you see the word OR. And let's say you spin the spinner and you want to find out the probability of spinning an even number or a number less than 3. So I'm just going to make a quick T-chart and throw the two categories up there. Okay, there's my T-chart, and I'm going to list all of the even numbers that appear on that spinner. So I have a 2, a 4, 6, and an 8. I would not say 10 because that's not on the spinner. And then I want to go to my second column and write down the numbers that are less than 3. Now when it says less than 3, you don't write down the number 3. Okay, do not include. So that would be 1 and 2. Now you want to look at these two categories and see if there are any events or numbers that you wrote down in both categories. So notice how I have a 2 that falls under both categories. It's both an even number and a number that's less than 3. This is what's known as an overlapping event. And when you have something that is overlapping, you want to cross off just one of them so that you don't count the 2 twice. So I'm just going to go ahead and really cross that out. Doesn't matter which one, but just don't cross off both. Okay, and then to find your probability, remember probability always has the total on the bottom. So total number of sections, well, that's going to be 8. So I'm going to throw that on the bottom. And then you just count up all the numbers in the two categories. So I got 1, 2, 3, 4, 5. And that's the number that goes on the top. I cannot simplify it. So the probability of you spinning an even number or a number less than 3 is 5 out of 8. Now let's say you want to find a number that is greater than 5 and just the number 2. So we want to go ahead and list all the numbers in those categories. Remember, you don't want to include 5. All right, so those numbers include the number 6, 7, 8. Of course, 9 and 10 and so on are greater than 5, but they're not included on the spinner. It only goes up to 8, so make sure you remember that. And just for one singular number 2, I'm just going to go ahead and drop that down. Okay, and notice how there are no numbers that are in both sections of the T-chart. This is what's known as a mutually exclusive event. Okay, and when that happens, there's nothing you can cross off. I'm still going to start with 8 on the bottom because that's the total sections of spinners, and then just count up what you have on the top. So 1, 2, 3, 4. All right, so I got 4 over 8, and of course that simplifies to 1/2 by dividing out that common factor of 4. So I would say that as I have a 1 out of 2 chance of spinning a number greater than 5 or a 2. I have a 1 out of 2 chance. Now I want you to get ready to pause it. Try this. See what the chances are or the probability is of either spinning the number 4 or an even number. Ready? Pause it. You should have gotten a 1 out of 2 chance. You just bring the number 4 down, you list out all the even numbers. 4 happens twice, you only want to count it once, so I cross 1 out. Count up what you have left. 4 over a total of 8 sections, 1 out of 2 chance. Ready for another? Pause. Oops, I said pause too soon. Okay, so find the probability of you spinning a 2 or spinning a 7. Now pause, try it, unpause when you want the answers. So you should have got 1/2. So you just bring the number 2 down, bring the number 7 down, count them up. You get 2 out of a total of 8. Simplify it. You get, ooh, no, I did that totally wrong. That should be 1/4. What is wrong with me? Okay, now think about it. Is this a mutually exclusive event or is this an overlapping event? Ready? Tell me. If you thought, because I know you didn't speak out loud to your computer, like really, no one does that. So, but if you said mutually exclusive event or thought it in your head, you'll be correct because there's no overlapping events. They both can happen without being in the same category. They both can exist simultaneously. All right, let's do one more. So you're going to try to find the probability of spinning a number greater than 6 or a prime number. Ready? Try it. If you had 5 out of 8, you are correct. Now, this comes with knowing what a prime number is. Just a quick little refresher. A prime number is a number with only two factors, 1 and itself. So, for example, the number 2, the only factors it has are 1 times 2. Same thing with 3, 1 times 3 are the only factors, and so on. 1 is not a prime or composite number, so I didn't even write that down. The only number that occurs twice is 7. You don't want to count it twice, so cross off one of them. Count up the rest, you get 5 out of 8 total sections, 5 out of 8 probability that you spin a number greater than 6 or a prime number. I really hope this helped with the OR compound probability, and good luck.